Did you know some flat earthers call it the atmos to avoid saying the word sphere? Let's explore this. Flat earthers have some very interesting ideas about the atmosphere. From claiming it should fly off into space if the earth is spinning, to asking why doesn't the atmosphere get sucked into the vacuum of space? Today we're unpacking their most common arguments and why science absolutely crushes them. Let's start off with one of the classic flat earth hits. If the earth is spinning at over 1,600 kilometers per hour, how is our atmosphere not being flung into space? Because the atmosphere isn't just sitting still. It's spinning with the earth. Just like how when you're on a train, you and the air inside the cabin are moving together. You don't feel the speed because everything's moving at the same pace, including the air. Also, gravity is doing most of the work. It holds the air tightly towards Earth's surface. Another common flat earth question: space is a vacuum. Shouldn't that suck the air off Earth? Nope. That's not how pressure works. There's no magical vacuum cleaner at the edge of space. The atmosphere gets thinner gradually the higher you go, until there's practically nothing left. We call that gradual change the pressure gradient. The air pressure is highest at sea level and decreases with altitude because there's less air above you pushing down. Here's the equation that describes atmospheric pressure. It's P equals rho GH, where P is pressure, rho, that's how you pronounce it, is the air density, G is the acceleration due to gravity, and H is the height of the air column above you. The pressure at any point is caused by the weight of the air above you. The higher you go, the less air is above, so the pressure drops.
Atmospheric pressure depends on the weight of the column of air above the surface, or in other words, it depends on how much air is above us. This way, if we are, for example, at sea level, we will have a large amount of air above us exerting pressure, since, as we can see, the air column is quite high. To get an idea of how much this pressure can be, the atmospheric pressure at sea level is around 1,013 hectopascals. But if we start going up in the atmosphere and we get to a higher altitude, we can see that there is now less air above us, which means that the atmospheric pressure here will be lower. Let's say around 850 hectopascals. So, in this order of ideas, if we go even higher, for example to the top of this mountain, there will be even less air above us, and therefore the pressure will be considerably reduced, obtaining values of around 500 hectopascals.
So when flat earthers can't explain gravity or pressure, they often claim that there's a giant invisible dome holding the atmosphere in. But let's be real. There is zero evidence of a dome. High altitude balloons have reached well over 30 kilometers. Rockets go hundreds of kilometers up. Satellites and space stations orbit Earth through the atmosphere and beyond, and no one's ever hit a glass ceiling. As much as you think those things are all fake. The atmosphere stays in place thanks to gravity and pressure, not because of a make-believe bubble. Atmospheric scientists have measured how pressure and temperature change with altitude across the globe. We understand how gases behave under pressure and temperature, and it matches what we see on our rotating round Earth. We also observe things like the Coriolis effect, which causes large air systems like hurricanes to spin in different directions depending on the hemisphere. That only makes sense on a rotating sphere. So no, the atmosphere is not getting flung off into space or being sucked out by some massive space vacuum cleaner or contained by a glass dome. It's held in place by gravity, explained by physics, and modeled by equations that flat earthers refuse to understand. Like, the pressure is literally the weight of the air above you. Simple, predictable, real.
Another important aspect of air is atmospheric pressure. We live at the bottom of an ocean of air. Gravity pulls on this massive layer of gas, creating pressure. The pressure is greatest at the bottom, the Earth's surface, the level where we live. In the few minutes you have spent watching this video, your body has been quietly using air pressure to move air in and out of your lungs. The diaphragm, a muscular membrane below your lungs, alternately contracts and relaxes, changing the volume of the body cavity, which changes internal pressure. Low pressure allows air at atmospheric pressure to move down the trachea into the lungs. High pressure forces it out. Without atmospheric pressure, we could not breathe.
If you found this helpful, like and subscribe. And share it with someone who still thinks clouds are trapped in a snow globe. Until next time, stay curious and stay grounded. Cool beans.